So in this next example for empirical formula, we are given a problem that consists of 3 elements already. So this is a lengthy calculation, but nevertheless, the steps remain to be the same. So let's go ahead and read our problem. It says a compound is analyzed and calculated to consist of 13.5 grams of Ca and then 10.8 grams of oxygen and 0.675 gram of hydrogen. Of course, we find the empirical formula of the compound. So first step, we list all the elements symbols. So make sure that we put the symbol only for the element. The first element is Ca, so that's already in symbol form, so we don't have a problem. Ca is for calcium. The second element is oxygen, and the symbol of oxygen is O. And the third element is hydrogen, so that is capital letter H. So in this case, we are given the mass right away, so that's why the second column is already for the mass. So we just have to copy whatever the mass is indicated in the problem. So for Ca, that's 13.5 grams. For oxygen, that's 10.8 grams. And then for hydrogen, that's 0.675 gram. Once we're done with that, we are ready to calculate for the mole, which is mass divided by molar mass of the element. Again, where do we get the molar mass of the element? From the periodic table of elements. So let's go ahead, put our solution first. So mass of Ca is 13.5 grams here, divided by the mass of Ca on the periodic table, that is 40.0. I'll just make it 40.08 to be consistent with the 2 decimal places. 40.08 grams per mole. And then we put the equal sign there. For oxygen, that's the mass is 10.8 grams divided by, again, oxygen is 15.999, which is just rounded up to 16.00 grams per mole, equals. And then lastly, for oxygen, for hydrogen, that's 0.67 grams divided by, hydrogen is 1.008 here. We'll just make it 2 decimal places, and that's going to become 1.01 grams per mole. And then once we put in place all the solutions, we can already cancel the unit that's not needed there, which is in this case, obviously, that's going to be the gram. And then after that, we're ready to do the division on the calculator. So the first one is 13.5 divided by 40.08. That's equal to 0.3. And the other 3 will become a 4 because of the 6. So that's 0.34 mole. The second one is 10.8 divided by 16. That's going to become 0.68 because the 7 is followed by a 5. So that's 0.68 mole. And lastly, it's 0.675 divided by 1.01. That's going to be equal to 0.6. And the next 6 will become a 7 because it's an 8 after. So that's 0.67 mole. So these are the answers for our mole. Let me just box it to make this clear for comparison later on. Once we're clear with our mole answers already, we can go to the divide by the smallest mole. So again, the technique is write first all the answers. So 0.34 mole. This one is 0.68 mole. And then this one is 0.67 mole, in which we put divide by the smallest. So the smallest among the 3 answers is 0.34. So 0.34 is our denominator. So you put 0.34 for every answer of the mole. Put 0.34 and then cancel first the units before you do any computations now. And then now we're ready to do it in the calculator. So 0.34 divided by 0.34, that will just be a 1. And then the second one is 0.68 divided by 0.34. That's going to be a whole number 2 here. And lastly, this one is 0.67 divided by 0.67 divided by 0.34. That's going to be equal to 1.97. Now, 0.9, I tell you, it's very close to a whole number. So the 1.97, we can just round it up to a 2. So it's very close to a whole number. So every time you have a 0.9 something, just round it up to the next whole number. So 1.97 is already a whole number too. So therefore, we get all whole numbers. So that means the next column will just have to skip this. And so our final ratios are 1, 2, and 2, which leads us to the final answer of the empirical formula for this. So CA will just be a 1. So CA is 1, O is 2, and H is also a 2. And because we don't have to write the 1, so therefore the final answer will just be CaO2H2. And this is our final empirical formula for this problem.